right, so I just cobbled together some kind of test rig and still learning about and testing lithium iron phosphate batteries. I've got them in my golf cart and I'm prepping to put them in my trawler. So we're just learning a few things here. I bought this 500 amp carbon pile load tester. And so it can put a load up to 500 amps, probably a little bit more, on whatever it is you hook to it. It's just got those giant alligator clips up there, not the best way. It makes a lot of heat, so I've got a fan on it. This is actually the remote indicator for the Epoch battery. This is not being used right now. This is not accurate, this gauge. I mean, it's going to be probably accurate to within 10 to 20%, but not great. And in addition, it just has a rotary knob to turn up the load. So that's not great either. Now I've got the app open, but the app only samples like every 30 seconds. It stores data in the log, I think every 30 seconds. You can't really get a good short-term indication of what's going on from the app. It's more of a long-term type of thing to monitor the state of the battery over long term. So to get our readings, we have this DC clamp meter, which will read in amps, and we're going to do a couple different tests. We're going to check 200 amp for 60-second rating of this battery, and then we're going to see how much we can pull out on short term, because the way that I think there's a lot of confusion about lithium iron phosphate battery amp ratings, especially in the golf cart world, because in the golf carts, everybody likes to mod their golf carts and pull huge loads out of them, do wheelies and go 40 miles an hour uphill and over jumps, whatever. People like to build carts to use them like that. So they get big controllers, huge amp loads, and they're always concerned about, rightfully so, about the ratings of whatever particular battery that they put in. But usually manufacturers are only going to give a couple of ratings. Usually that is a continuous rating and then some type of peak rating. Now the peak rating, the continuous rating is pretty solid. I mean, I'm sure there's going to be a fudge factor. We've already seen from the previous video that I made for a continuous rating for the Epoch. It's much higher than 120 amps. Well, it's not much higher than 120 amps. I did it for 22 minutes at 160 amps just to see what it could do. Now, this 120 amps on their rating is what you should never exceed over a long period of time. That's the engineering rating with a little bit of fudge factor, I'm sure, put into it. But this is, if you're designing a system, you should never exceed that. We pulled 160 amps for 22 minutes. Another 10 minutes and the battery would have been dead. And there was no indications of it shutting down, although the MOSFET temperature probably would have shut it down at some point. But at 120 amps, you know, you should be able to do that all day long till the battery is depleted. Now this rating here, the 200 amps at 60 seconds, we're going to test that, and I'll make sure that that's correct before we test it. But that's what they rate at a peak rating. But the way that outputs usually work in amperage for many things that consume amperage and many things that put out amperage, they just give a nominal rating, kind of like horsepower. Peak horsepower, they always give the number of peak horsepower, but that doesn't tell you the whole story about the performance of the engine. Just like this number does not tell you the story of all of the peaks. The peaks of a battery are going to be something like this. So, you know, on this scale, you have amps over here with 500 being up here, 250 and 0, and then you have the time scale down here. Very short time scale, 0.01, 3.0 seconds, 60 seconds, continuous. So these are the two ratings, 120 amps, continuous rating, 200 amps for 60 seconds. But if you were to shorten the time scales, especially say on a golf cart, and you were just going to floor it momentarily, as the cart accelerates, the amp draw will drop. Just because of the nature of how the system works, the amp draw will drop. So a battery like this, and every other battery that rates it at 200 amps at 60 seconds, if you're only doing it for 3 seconds, it's going to be much higher. And that's just the nature of the way it's built and the nature of electricity and heat and various other things. So this would be something like the scale in a shorter, you could probably pull 500 amps out of this, and this is just a guess. This is just a guess, for shorter periods of time. I wish that they would have more ratings, and just give a standard of 0.5 seconds, 5 seconds, 10 seconds, 30 seconds, 60 seconds, just for things like starting of electric motors, like a golf cart motor, or various other things, inrush loads, which are split-second loads, but then they settle down into something more continuous once everything's up to operating speed. So using this, we're going to test what this can take, and we're going to try to plot it. It's very, very difficult to do with the equipment that I have, but we're going to try to see if we can find out a little bit of information, including exceed. We're going to exceed the capability of the battery, and hopefully it shuts down as advertised. That's an important safety feature, so we're going to test it. It's going to be a little rough. I hope you can. I've got a fan on there to cool that thing down because that generates a lot of heat. Hope that's not interfering with the sound. But I'm going to try to set up a few tests here, and it's going to be a little rough around the edges, but we'll see if we can gather some information and hopefully inform ourselves about the nature of these batteries and these parameters here. All right, the first test we're going to do, seeing as how I've already done this one, and I'm fully satisfied with that, we're going to see if we can replicate this 200 amps for 60 seconds. I've got the stopwatch out. I have the meter on to measure it. This is essentially just a dial I'm going to turn until I can approach 200 amps, and we will check the time. I've already got this dial turned to where this is like an infinite dial. It's not like it has stops on it or anything. I've got the dial set, so as soon as I start turning it, the amp load should go up. We're going to roughly get that needle off the seat, and then I'm going to watch this until we get 200 amps. So let's do that, and then I'll start the stop button. Okay, so we got 150, a little higher, a little lower. It's very difficult for me to control. That's good enough. I don't think my that is this beeping. So we got 9 seconds. We're a little higher. Let me see if I can turn it down just a hair. Probably because it's heating up. Like I said, it's going to be a little bit of a rough test. Still climbing because it's heating. Let's just go with what we got. It's going to be very difficult. It is climbing. I expect this thing to start smoking here. Hopefully it'll last 60 seconds. So we're pretty close to 200. We've got 42 seconds, so we had a little bit of amps on it for a split second before we started the clock. So it's exceeding 200 amps now, so we're kind of getting an average. 53 seconds. I can smell the smoke coming off this tester. So there we go, 60 seconds, 230 amps. Wow, let's shut this thing down. All right, so we had 200. It started off at 200, went down to about 195, and then crept up to 230. So average, most definitely we exceeded 200 amps for 60 seconds. So this one is a yes, and this one is a definite yes. So in this case, we met the parameter and then some of 200 amps for 60 seconds. So we've got this, we've got this. We're going to move up the scale, and I'm going to set this to hold a peak, and we're going to momentarily turn it up to various peaks and then turn it back down. But I have to wait for my little carbon pile load tester to to cool down. If you were here, you would smell a bunch of smoke, or a bunch of burning, I guess you could say. So anyways, let me shut it down, let it cool everything down, and then we'll repeat the test at a higher amp load. All right, let it cool down a little bit. And basically what we're going to do here is everything's going to happen so fast that I cannot use a stopwatch. So we're just going to count. Like I said, this test is very rough around the edges. You know, we're talking about time scales of 3 to 5 seconds here, and I'm just going to count 1001, 1002, 1003. And that's just a general idea. And we're going to shoot for, at first, we're going to shoot for 300 amps. (1001), 1002, it's shut down. So that was about 2 seconds at 300 amps. And that was our maximum, 309 amps. So let's plot that here. And that's about where I had the graph. So we're going to call this about 300 amps right here at approximately 2 seconds. We started pulling a current, and it took me a second to get up there, so it's not the greatest test. So I'm going to say that that's about 300 amps. Let's just call it 3 seconds. 300 amps. But that was to shut down, so it's going to be less than that. So that's when it shut down. Tells us a little bit more of piece of information. And then we're just going to turn it up now. I need to get rid of this. All right. So now I actually discharge overcurrent protect, I'm sure is what that is. Discharge MOSFET is off. So you can get a fault and you can see what's going on the internal life of the battery with the app. So we gotta wait about, I've done this already, so I already know that basically we have to wait. Over here, the battery is shut off. If I try to turn it back on, it's back on. I've already waited a few seconds. So discharge MOSFET is on. The the discharge overcurrent protection is now off. And so that's a nice feature that if you have, especially in a boat or a golf cart for that matter, but I like it especially in a boat. If you're pulling a huge load, when the battery overcurrents, it's going to shut it down and it won't restart until you hit that button again and long press the button for, I think, 3-4 seconds. Some batteries will actually reset by themselves every so often, 60 seconds, 30 seconds, whatever. Others, you actually have to apply voltage at above a certain level to reset it, which could be a problem if you're on a boat and something, you arc something or disconnect the wrong wire and put a huge load across it. Well, then you have to drag out a charger or a power supply or something to reset it. Or if it's automatically resets and you haven't corrected the problem, now you have to start disconnecting battery cables to make sure you don't keep overloading it. In this case, having a button on a battery is a fantastic thing. Having an app to tell you what the problem is a fantastic thing. In this case, if you had overloaded something on your boat, you're using an induction cooktop and an inverter or something like that, and you overloaded the battery, it shut down, you could start isolating all your loads on the DC panel one at a time. Or if you absolutely knew which one it was, just shut it off. Then you can reset everything, get your systems back up and running. So we're going to repeat this test. We'll try to shoot for like 400 amps just for a split second, just to see if it'll take it. And then that will pretty much conclude what we're going to do. So, all right, so we've got the meter set to hold the maximum. I just want to momentarily turn this thing up and see what we can get for a quick peak. Okay, there we go. All right, so there's a good example of a very high peak for a very short duration. You can rewind this and kind of check and see what the time scale was. It's probably less than a second, although there is, it compiles the totality of the load over time. So as you're turning it up, all that counts. So this is why it's so difficult. If in a perfect world, you would have a load of 438 amps set, and you would apply it immediately to the battery for a particular exact time. and you would test it that way. And this way we've got to turn knobs and all this other stuff. So that was less than a second. Let's just say it was probably longer than 0.01 seconds. So that was 438. So we're somewhere around here for probably 0.05, something like that. So that just goes to show you that it is correct, and no overcurrent protection happened. So I was able to turn it up and down fast enough to where it did not overcurrent. Now let's overcurrent it. Let's just overcurrent. Let's remove this min max here. So we are on it, and we're just going to turn it up and watch for the red overcurrent. There it is. That was a full overcurrent. SC protect. We did overcurrent it. It did shut down as it was supposed to. There is no output. The discharge MOSFET is off. Make sure this is turned all the way down. And let's see if we can get this to reset this quickly. I don't think it will. 1, 2, 3. It just blinks, so it's not ready to reset. Yeah, not ready to reset yet. All right, so there it goes. Reset. That's probably going to go off here momentarily. There we go. Discharge MOSFET is back on, and we are now reset. So we kind of drew this plot, very rudimentarily checked it, and that's about what it is. And you can kind of apply this to any battery and just know that if they have some 10-second peak, this is a very generous engineering parameter, 200 amps for 60 seconds. This 60 seconds tells you that they're being pretty generous, and that the shorter time scales are going to be much higher. So when you see a battery, a 100 amp hour 12 volt battery that has a maximum output of 200 amps, but it's for 3 seconds, down here. So if it's rated for 200 amps maximum, or max discharge 200 amps for 3 seconds, you can place that 200 amps here, and you're basically going to take this whole curve and lower it. So on the max rating, everybody seems to have similar ratings. They'll usually do a 100 amp rating for a certain time period, and then they'll do a max rating, which for most people, it's 200 amps, right? So everybody thinks, well, 200 amps is 200 amps on the max discharge current. No, whoever has the longest time period at 200 amps, you can just take this curve and adjust it up or down on that time scale, and the one with the longest time scale is generally going to be the best battery and have the highest peaks for discharge rates. I hope that makes sense. Just kind of sharing what's in my brain talking, but I hope that makes sense. But I believe that that's generally true. So that's pretty interesting. All right, we'll do more later. I think I'm done testing these batteries. I'm very, very satisfied with them. The only thing I would like is if all these codes here for trouble codes, I'd like a definition. I'd like a legend somewhere for what each one means. And then the other thing is, this was supposed to beep. At least I thought it was. I could just be in error on what I thought it was going to happen. I thought that this was going to give an audible beep, but it did not. So I'd like to see that as well. And I think they're coming out with a new battery. I think it's 480 amps, 12 volts. And I believe that interfaces with the Victron stuff, which is what I have. So more than likely I'll be buying one of those for the boat. And then, believe it or not, these might go in my mower. So anyways, more later.